Everyone, and good day. So today we'll continue with the next subtopic, which is come back to 3.3 inverse Laplace transform. So what we will see today is the subtopic 3.3.1, which is the elementary inverse of Laplace transformation. Okay, so today we will see how to do inverse Laplace transformation by comparing or referring to the table. Okay, if you remember, before this we have learned from the function ft. Okay, when we do a process of Laplace transformation, where the symbol of Laplace transformation is this one. Okay, when we do the process of Laplace transformation of ft, then what you will get in return is the function of capital F in terms of s. Okay, so every times you have done with the Laplace transformation, what you will get is the function in terms of s. Okay, it's always in terms of s. Whatever function, whatever variable you have in your function, after the Laplace transformation, you will always have a function in terms of s. Okay, so now what we want to see today is how from the Laplace transformation, the function of f in terms of s, we want to get back our original function ft here. Okay, so we can get back this original function ft by using the process called as inverse Laplace transformation, or the symbol of inverse is like this. Okay, means that if before this we have learned how to find the Laplace transformation of the function ft, okay, and what we have in written as the product of the Laplace transformation of ft is the capital F in terms of s, which is the function f in terms of s. Okay, but today what we will see is the inversion of the Laplace transformation, where we will inverse the Laplace transformation of the function fs, okay, for us to get back our ft. Okay, so when you have ft, okay, you do the Laplace transformation on ft, what you have is fs. And if you have fs, you do an inverse Laplace transformation, which is the symbol is like this. What you get back is ft. So this is the relationship between the Laplace transformation and also inverse of Laplace transformation. Okay, like in Laplace transformation, we also can find the inverse of Laplace transformation by referring to the tables. Okay, so you will see the Laplace transformation that you have is close or simple or related to which function ft here. Okay, so let's see how can we use this table to find the inverse of our Laplace transformation. Okay, if before this, when we want to do a Laplace transformation by using a table, we refer to the table to get the formula, okay, to find fs. But now when you have fs, you want to find ft, you just need to refer to the table and find the closest form, okay, from fs to get what is the ft. Okay, the suggested hint is you need to see the denominator part. Okay, for the first one, when you have the denominator equal to s to the power of 1, okay, you have s to the power of 1, single variable here. Okay, so this one will be the function of constant a. Okay, for example, if you have fs equal to 9 over x. Okay, now you have the denominator s to the power of 1, therefore you know this one will related to the ft equal to constant a. Okay, so your constant a here is equal to 9. So automatically what you will get for your function here is ft equal to 9. Okay, if you have your fs equal to 2 over 3s, for example. Okay, so now your s is to the power of 1, so you know directly this one is related to the first function ft equal to constant a. Okay, but what is the constant a is the whole fraction here, 2 over 3. So you will have your ft equal to 2 over 3. Okay, this one is for the first one. When you have the denominator s to the power other than 1, for example, you have s to the power of 3, s to the power of 2, s to the power of 4. Okay, that function, that Laplace transformation function fs will give you the original function t to the power of n. Okay, if previously you see the denominator you have s to the power of 1, automatically you know this one is ft equal to a constant a. If you have your denominator a single s to the power of other than 1, okay, means that your ft is in the form of t to the power of n. Okay, so for example, if you have your fs equal to 4 over s to the power of 3, for example. Okay, so you see the denominator. Okay, it's easy for you to find the ft, just refer to the denominator. So now you see your denominator is single s, but the power of s now is not 1 anymore. Okay, the power of s is 3. So this one we related to the function of ft equal to t to the power of n. Okay, where if you see the formula from ft to fs, you see s is n plus 1. Therefore, your equation here can be written as fs is equal to 4 over s2 plus 1. Okay, so you know now your n is equal to 2. Okay, so you can write your equation ft equal to t to the power of 2. But this one is not yet the final answer because you need to times the t to the power of 2 with a constant m. Okay, so how to find the constant m? The formula to find the constant m is n factorial. You time with the constant m, you must get the same value as in the numerator. We see in the numerator you have 4. Therefore, n factorial times with m must be equal to 4. So you know now your n is equal to 2. Therefore, you have 2 factorial times with n is equal to 4. 2 factorial is equal to 2. So you have 2m is equal to 4. So m is equal to 2. Therefore, your final function ft is equal to 2t to the power of 2. So let's say we have another example. Fs equal to 4 over 3s to the power of 5. Okay, so if you can see in denominator is involve s to the power of more than 1. So we know that this one is related to the function of t to the power of n here. Okay, so this one you can write as the function of fs equal to 4 3s to the power of 4 plus 1. So directly from here you know that your value of n is equal to 4. Okay, so you can write down your function ft equal to m t to the power of 4. Okay, so now you want to find what is the value of m, where you can use the formula. The value of m can be found by using n factorial times with m. You will get what is the coefficient that you have here. So here you have your coefficient equal to 4 over 3. Okay, so you have m factorial. So you know that your n is equal to 4. Therefore, you have m factorial 4 factorial times with n is equal to 4 over 3. Okay, so 4 factorial is equal to 24. So 24 times with m is equal to 4 over 3. Therefore, you have m is equal to 4 over 3 times with 1 over 24. Okay, which will give you 1 over 18. So now you can write your ft equal to 1 over 18 t to the power of 4. So this one is your ft. We have seen the function fs which involve the denominator with single s or s itself. Either we have s to the power of 1 or s to the power of more than 1. Okay, when we have s to the power of 1 in denominator, therefore we know that that function is related to ft equal to a, which a is a constant. And when we have the s to the power of more than 1, we know that that Laplace transformation is related to the function ft equal to t to the power of n. Now, if we have the denominator is not a single s, but you have s minus other constant a. Okay, so if you have in the denominator the s to the power of 1 minus with any constant or plus with any constant, this one will be related to the function ft equal to exponent at. Okay, for example, if you have your fs equal to 4 over s minus 3, okay, so you have s to the power of 1 in your denominator, and it's not just s, but you have negative 3 beside s. Therefore, this one is related to the function ft equal to exponent at. So you need to know which one is your a. So if you compare with the table here, your a is here. 3 is your a. Okay, therefore you can write the function ft for this Laplace transformation equal to exponent at. Okay, but you have a constant m in front. Okay, so how to find the constant m in front here? The constant m will be equal to the constant that you have in your fs. Okay, so now you have constant 4, therefore your ft will be 4 exponent, your a is 3t. Okay, you have your fs equal to 5 over 2s minus 4. Okay, you can see in your denominator now, you not only have s, but you have s minus with some constant here. Okay, so this one will be related to the third function, which is exponent at. But you need to remember that s need to have coefficient 1. Okay, here you have 2 as the coefficient for s, so you need to factorize 2 out. Okay, so what you need to do is you need to factorize 2, so we can write our function fs here equal to 5 on the numerator, 2 out of the bracket, then you factorize 2 here, you will left with s minus 2. Okay, so now you have the coefficient for s equal to 1. Okay, so your a is equal to the one beside s, which is 2. So this one is your a. Therefore, you can write your function ft equal to m exponent at. So your a is 2. Now we want to find what is the value of m, and m is equal to all constant that you have in your fs. So your constant here is not only 5, but you have 5 over 2 here. Okay, therefore your equation now become ft equal to 5 over 2 exponent to t. Example, if you have fs equal to 3 over 5s plus 2. Okay, and you can see in your denominator here you have s to the power of 1, but you still have another constant plus 2 beside s. So this one is related to the third function here, okay, where your ft will be in the form of exponent at. Okay, but the thing that you need to remember is the first one, your s coefficient must be equal to 1. So whenever you have it's not equal to 1, you need to factor it out. Okay, so you can write your function here as fs equal to 3 over 5. So here left only s, and here you need to divide by 5, therefore you will have 2 over 5 inside. Okay, that one the first one. The second one is, if you compare to the table here, you have a negative sign in front of the constant, but now you have a positive sign. Therefore, you need to factor out the negative sign here. So you can write your function fs is equal to 3 over 5 s minus, so you have in bracket minus 2 over 5. So now you can see which one is your a. So your a is here. Okay, your a is equal to negative 2 over 5. Okay, so the ft for this fs will be m exponent at. So your a is negative 2 over 5. Just write down negative 2 over 5t. Now we want to find what is our m, and for this case you need to remember m is equal to the constant exists in your fs. So here you can see the constant in your fs is equal to 3 over 5. Okay, so you have your final solution ft is equal to 3 over 5 exponent negative 2 over 5t. So this is how, from a Laplace transformation, you can change it into the function ft. We see when our denominator is in the form of single s to the power of 1, which related to the first function ft equal to constant a here. Then if we don't have the power 1 but we have single s with the power more than 1, then it's related to the function t to the power of n. We also have seen if our denominator is s to the power of 1 but it has a constant beside, so it's related to the function of exponent at. So when you have in the denominator is s to the power of 2 with any constant, okay, either is positive or negative, so it's related to the function sine, cos, cosh and sine hyperbolic. Okay, so what is the difference between sine and sine hyperbolic is just a sine here. Okay, and what is the difference between sine and cos is just the numerator. Okay, so if you have the numerator equal to a constant, therefore it will be related to the sine at or sine hyperbolic at. But if you have the numerator in terms of variable s, therefore it's related to the function cos at and also cos hyperbolic at. Okay, so for example, if you have the function of s equal to 4 over s square plus 9 square plus 9. Okay, this one is not case number 1 because you don't have s to the power of 1. In fact, you don't have single s in the denominator. Also not to the case number 2, you have s more than 1 but you have a constant beside s. Okay, not the case number 3 because the case number 3 your s must be in the power of 1. So this one is the case either sine or sine hyperbolic. Why? Because you have a constant in the numerator here. Okay, so this one can be written as fs equal to 4 over s square plus 3 square. So if you compare this equation with your table, you know that this 3 is equal to a. Okay, so you can write the function ft for this fs is equal to sine at, which is your a is equal to 3. How do you know sine but not sine hyperbolic? Because the sine here is plus. If the sine here is minus, then you will have the function sine hyperbolic 3t, and it's not yet solved, or it's not yet the final ft because you will have the constant m in front here. Okay, so the constant m will be equal to any constant exists in your fs or in your Laplace transformation here. So if you can see here, you have a constant for the constant m here, so you can use the formula to find the constant m, where a times with m you will get the coefficient that involve or exist in your Laplace transformation. So for here, the coefficient is equal to 4. So you have your a is equal to 3, therefore you have 3 over m is equal to 4. Okay, so m is equal to 4 over 3. So your final function ft for this function is equal to 4 over 3 sine 3t. So you have fs equal to 1 over s square minus 3. Okay, so this one will be related to either the function sine at or sine hyperbolic at, because you now have the s to the power more than 1 and also a constant together in the denominator. Okay, but now because of you have the sine here is equal to minus, therefore this one will be related to sine hyperbolic at. Okay, but before we continue, we need to make sure the denominator is in the form of x square minus a square. Now you only have s square. Okay, you need to transform this 3 to become any constant square. Okay, so you can write your fs equal to 1 over s square minus sec3 square. Okay, because sec3 to the power of 2 will give you the original function here 3. Okay, so now we already write our function as 1 over s square minus sec3 square. So you have the same denominator as sine hyperbolic at here. So you can define or you can find what is the value of a. So sec3 is now the value of a. Okay, so you can write your function ft equal to m sine hyperbolic at. So your a here is sec3t. Okay, now we want to find what is the value of m, and the formula to find the value of m is a times with m. You must have the equal value as the coefficient exists in this function. So the coefficient that exists in this function is only 1, therefore a times set m is equal to 1. Okay, so you have your a is equal to set 3 times m is equal to 1, therefore your m is equal to 1 over set 3. So your final ft will be 1 over set 3 sine hyperbolic set 3t. So this is your answer. The function fs, when it's involved in the denominator as to the function of 2 with the constant, either positive constant or negative constant, and the numerator is a constant. So it's related to the function sine at and also sine hyperbolic at. Okay, but now if you can see, we have the same form of denominator, but in the numerator you have s. Okay, you have the numerator in the form of constant times s. Okay, so for this case, if you find the fraction or the Laplace transformation in this form, this will related to the function ft equal to either cos at or cos hyperbolic at. The difference between these two is only the sign here. If it's minus, then it related to cos hyperbolic at. If it's plus, then it's related to the function ft equal to cos at. So now, same as the sign before, the first thing you need to make sure is you need to write your denominator in the form of s squared plus a squared. S cannot have any coefficient, then s squared plus a squared must be in the form of your denominator must be in the form of s squared plus a squared. So let's write our function here. We can write our fs equal to 3s over s squared plus 2 squared. So now you already have the denominator in the form of s squared plus a squared, where you directly know that your a is equal to 2 here. Okay, the second step is you need to take out all the coefficient that you have or the constant that you have in this fraction. Therefore you can write your function fs here as 3s over s squared plus 2 squared. Okay, so now you can write your function ft equal to m cos 2t. Okay, cos at, your a is equal to 2, so you have m equal to cos 2t. How to find the value of m? The value of m is equal to the coefficient that you have here. Okay, so now you only have 3, therefore your ft is equal to 3 cos 2t. You have fs equal to 4s over 2s squared minus 10. Okay, the first thing you can see here is your denominator involving s to the power of 2 minus with constant, and your numerator is the constant with variable s. So automatically you know that this one is related either to the cos or cos hyperbolic function. Okay, but then if you can see in denominator you have negative sign here, therefore directly we know that this one will related to the function ft equal to cos hyperbolic at. So the first step is you need to write your denominator in the form of s squared plus or minus a squared. Okay, so now you have 2 as a coefficient of your s squared. Okay, from the table, your s squared must have coefficient equal to 1. Therefore, the first thing you need to do is you need to factor out 2. So what we will have for our fs here, it will be 4s over 2. So in the bracket, you left this one as s squared minus with 5. Okay, then you can take out the coefficient that you have in this function. So we have fs equal to 4 over 2, and in bracket we left only s over s squared minus 5. Okay, so 4 over 2 can be simplified to be 2. So this one is left only 2. Okay, and now we need to make sure that our denominator is in the form of x squared minus a squared, but you only have 5 here. Okay, so you need to find what is the value that you can square so that you get the value equal to 5. Okay, so you can write your function fs now as 2. In the bracket is s over s squared minus sec 5 squared. Okay, because sec 5 power of 2, you will get back your 5 here. Okay, so now you know what is your A. Your A will be cert 5. This one is your A. Okay, and you can write your function ft. Okay, ft is equal to m cos hyperbolic at. So your A is cert 5t. Okay, so what is your m? Your m will be equal to the coefficient exists in your fs. So here you have a coefficient equal to 2, therefore your m is equal to 2. Okay, then you have your final function ft is equal to 2 cos cert 5t. So this one is the answer. We want to see how to find the Laplace transform when how to find the inverse Laplace transform when it's involve the function that have s as denominator and exponent as numerator. Okay, so before this we have concern about the function when it's involved in the denominator s to the power of 1. Okay, here, which is case number 1, but then the numerator is equal to constant. Now you will have the same s to the power of 1 as denominator, but the numerator now is in the form of exponent. Okay, exponent ds, negative ds or positive ds. So this one will directly related to the unit step function ut minus d. Okay, so what you need to do is you just need to know what is the value of d. For example, if you have the function 8 exponent 3s over s. Okay, so this one is fs. We want to find the inverse Laplace, which is ft. Okay, so when you see your denominator is s to the power of 1, but you have exponent in your numerator, directly you know this one is the one that related to the ft equal to unit step function ut minus d. Okay, so you can actually write your function ft as a u t minus d. Okay, or just put m as a constant here. So m times with u t minus d. So you need to know what is the value of d, and d here must have the negative value in front. Okay, you have positive here, so you write your fs is equal to 8 exponent negative 3, negative outside. Okay, negative outside, negative 3 to the power of s. So negative and negative will give you positive. Okay, over s. So you now know that the value of d from this function is equal to negative 3. Okay, so we can write our ft as m times u t minus your d is equal to negative 3. Okay, so how to find m? M is just a coefficient that exists in your fs. So here you can see your m is equal to 8. This one is the coefficient exists in your function fs. Okay, therefore you can write your final ft as 8 u t plus 3. Here now, if you can see your fs is equal to 4 exponent negative 4s over 3s. So if you see in the denominator you have s to the power of 1, but you have exponent in your numerator. So when you find this kind of function, therefore you know it's related to the unit step function ut minus d. Okay, so we can actually write our ft equal to m times with ut minus d. Okay, so for this case, it's easier for you, or it's recommended for you to take out the coefficient outside. Okay, therefore if you take the 4 over 3 outside, what you will have in the bracket is only exponent negative 4s over s. So this one is more easier for you to see. Okay, so now from this function you know that the value of d is equal to 4. Directly this one is your d. Okay, so we can write our function ft as m times u t minus 4. Okay, how to find m? M is the coefficient that exists in your fs. So the coefficient here is 4 over 3. Directly you can get your ft equal to 4 over 3 u t minus 4. The function fs when is involved in the denominator, the single s to the power of 1, and in the numerator you have the function exponent. Okay, for now we only have fs in the form of exponent. Okay, so when you find this kind of function, you know that this one will be related to the ft equal to delta t minus d. Okay, so you just need to know what is the value of d. Okay, so from this function, let's say you have fs equal to 4 exponent negative 5s, you can directly see that your d is equal to 5. Your d is here. Okay, so your d now is equal to 5. So you can write your function ft equal to m times with delta t minus d. So your d is equal to 5. So you have delta t minus 5. So how to find the value of m is again the coefficient that involve or that exists in your function f here. So now you have your m is equal to 4. Therefore you will have your ft is equal to 4 delta t minus 5. Function fs equal to 2 over 3 exponent 5 over 3 to the power of s. You see your function here only involve the exponent function. Therefore this one we related to ft equal to delta t minus d. So you need to know what is the value of d. Your d come from the coefficient of from the exponent of this exponent function, but you must take out negative sign. Okay, here. So you can write your fs equal to 2 over 3 exponent negative 5 over 3s. So from here, you know that the value of d is equal to negative 5 over 3, because you see the general form here must have negative outside and also s. Okay, so we have negative outside and also s, therefore our d is equal to negative 5 over 3. So we can write our function ft equal to m delta t minus our d is negative 5 over 3. Okay, how to find the value of m? M is any constant that exists in your fs here. So you can see here your m is equal to 2 over 3. Okay, therefore what you will have is ft equal to 2 over 3 delta t plus 5 over 3. So this one is the function.